Hi, what's up? This Eric on Owen Finance, your gateway to the ever-evolving world of crypto, but also smarter investments, sharper financial insights, and much more. Ready to level up your financial game? Let's dive in. Imagine a digital ledger that isn't controlled by any single person or institution, but is instead maintained by thousands of computers all around the globe. That's the fundamental idea behind blockchain technology in the context of cryptocurrencies. Instead of trusting a central authority to manage and verify transactions, the power is distributed among all participants in the network. Transactions become transparent, almost impossible to manipulate, and theoretically accessible to anyone who wants to inspect them. Blockchain, at its core, is basically a chain of blocks. Each block contains a batch of transactions, plus a reference, or a hash, that connects it to the previous block in the chain. When a new transaction is made, like sending or receiving cryptocurrency, it's grouped together with others, cryptographically validated, and added to the chain. Because every block references the block before it, no one can change or remove transactions without altering all subsequent blocks. This makes it incredibly difficult to tamper with, given the sheer computing power needed to rewrite the entire ledger. One of the most well-known mechanisms that blockchains use to validate transactions is called proof of work. Proof of work is famously used by Bitcoin, which is the largest and most recognized cryptocurrency today. In proof of work, computers on the network, often referred to as miners, compete to solve a complex mathematical puzzle. The first miner to solve this puzzle earns the right to add a new block of transactions to the blockchain and is rewarded with some amount of newly minted cryptocurrency. Once that block is added, all other nodes, computers, in the network verify the block's validity. The biggest advantage of proof of work is that it's highly secure. To corrupt or manipulate the blockchain, a bad actor would need to control more than half of the network's total mining power. This is commonly referred to as a 51% attack. Given the massive scale of Bitcoin's network, pulling off such an attack would be enormously expensive and practically unfeasible. However, proof of work has some notable downsides. One of the primary criticisms is the large energy consumption. Miners use specialized machines that burn through electricity, which has environmental implications. Another drawback is scalability. Proof of work can be slower than other mechanisms, making it challenging for some networks to handle a high volume of transactions. An alternative approach is proof of stake, used by cryptocurrencies like Ethereum after its move from proof of work to proof of stake. In this system, instead of miners, you have validators who are chosen to propose and validate blocks based on the amount of cryptocurrency they stake, basically locking up their coins as collateral. The more coins they stake, the higher their chances of being selected to validate the next block, and the more they stand to lose if they validate fraudulent transactions. This mechanism is far more energy efficient than proof of work, because you don't have thousands of computers competing against each other to solve complex puzzles. The advantages of proof of stake include reduced energy usage, faster transaction processing, and easier scalability. However, a disadvantage can be the rich get richer effect, where those who already hold a lot of coins have a higher chance of validating blocks and earning rewards, potentially centralizing power among a small group of wealthy participants. Another consensus mechanism is proof of space, sometimes called proof of capacity. Cryptocurrencies like Chia utilize this model. Instead of using processing power, proof of space uses storage space as the resource. You plot your hard drive with cryptographic data, and the network selects a winning plot to confirm the block. The advantages include lower power consumption compared to proof of work and a less hardware-intensive process. On the flip side, it can drive up the cost of storage and hardware, and if a large player corners a lot of disk space, it could lead to partial centralization in terms of data storage resources. Each of these mechanisms, proof of work, proof of stake, proof of space, and others, aims to ensure that no single entity can unilaterally control the network. They all offer different trade-offs between decentralization, security, energy usage, and transaction speed. The most famous example of proof of work is Bitcoin. Here's how Bitcoin's blockchain works in a bit more detail. When someone makes a transaction, it gets broadcast to the network. Miners pick up those transactions, form a new block, and begin attempting to solve the cryptographic puzzle. This puzzle is basically a race to find a number, a nonce, that, when combined with the block's data, produces a hash, an encrypted output, that meets a certain requirement, usually a hash value with a specific number of leading zeros. Because finding such a nonce is mostly trial and error, it requires a lot of computational effort. When a miner finds the right nonce, they broadcast their solution to the network. Other nodes verify the solution quickly because hashing is a one-way function that's simple to validate. If it's valid, the block gets added to the chain, the miner earns the block reward, and everyone updates their copy of the ledger. This entire process repeats roughly every 10 minutes. Over time, these blocks stack on top of each other, creating a permanent, transparent record of all Bitcoin transactions ever made. Bitcoin's creator, known only by the pseudonym Satoshi Nakamoto, remains a mystery. Nobody publicly knows their real identity. This has interesting implications. There isn't a specific person the government can charge, sanction, or hold responsible for Bitcoin's operations. Plus, because the network is spread across thousands of computers worldwide, there's no central point of failure to shut down. It's as if there's no off switch. For some, this is the ultimate expression of decentralized power. For others, it's a regulatory and legal headache. Either way, it's a monumental shift in how we think about money and control of financial networks. Beyond digital currencies, blockchain technology has some really intriguing potential applications. It could be used for secure voting systems, ensuring transparent and tamper-proof elections. It can also track the supply chain for products. Imagine scanning a QR code on your groceries and confirming exactly where and when each ingredient was sourced. Some even envision using blockchain for decentralized autonomous organizations, DAOs, where rules and regulations are coded into smart contracts, removing the need for a traditional hierarchical management structure. As for the future, many predict that blockchains will continue to evolve and find new niches, especially as concerns about data privacy and trust in centralized institutions grow. Governments and major companies are already experimenting with their own blockchain-based projects. Still, blockchain isn't a magic bullet. Scalability, regulation, environmental considerations, and public awareness remain hurdles to mainstream adoption. Now, let's pause and consider what this all really means. We've become used to trusting intermediaries to verify our transactions and our identities, and to store our data. Blockchain opens up a path to do all that without relying on any central authority. It's almost like a collective memory that everyone contributes to and verifies all at once. It could be a glimpse into a future where transparency and security aren't just buzzwords, but built-in features of everyday systems, whether that's in finance, governance, or how we manage personal data. So the next time you hear someone mention blockchain, think about how it's not just about fancy digital coins, but a revolutionary shift in how we can organize and secure information. The real power might lie in how these decentralized ledgers can reshape the very foundations of trust and cooperation in the digital age. Maybe the question isn't so much if blockchain will change our world, but how we'll shape this technology to serve us best. Thank you for watching. If you liked the video, don't forget to give a like and subscribe to support us. If you are interested in our premium content, please also visit our Patreon. You can find the link in the description. Thank you, and take care of yourself and your finances.